Today's lesson is on angles of elevation and depression. An angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the line. So looking at the people in the control tower down here, they're looking up at the plane that's forming the line of sight to a point above the horizontal line, and the horizontal line would be straight out from them. So this angle right here is an angle of elevation. It's an angle that is positive, opening up from the horizontal line. An angle of depression is the angle formed by a horizontal line and a line of sight to the point below the line. So this would be here at the pilot. He has to look down to look at the control tower, and the horizontal line is straight out in front of him. So his angle opens down here. So that would be an angle of depression. Just a quick note here, in this picture, the horizontal lines are parallel. So angles 1 and angles 2, and angle 1 and angle 2 are alternate interior angles. That means they're on the inside, but on the opposite sides of the picture. That means that those angles are congruent. So the measures of those angles are the exact same. Example 1, we have to look at each angle as an angle of elevation or an angle of depression. So letter A here says take a look at angle 3. So here is the horizontal line, and here is the line of sight that creates that. So that is going to open underneath the horizontal line, so that is an angle of depression. Angle 4 for part B, here's your horizontal line for angle 4, and here's your line of sight. The line of sight is opening up from the horizontal line, so that is an angle of elevation. Angle 5, this would be the horizontal line, and here's the line of sight. You're looking down from the horizontal line, so that would be another angle of depression. And then lastly, we have angle 6 here. There's our horizontal line. Here's our line of sight. That is opening above the horizontal line, so that would be an angle of elevation. For example 2, an air traffic controller at an airport sights a plane at an angle of elevation of 41 degrees. So here's our traffic controller, and here is our plane. And it says that the angle that's formed here is 41 degrees. The pilot reports that the plane's altitude is 4,000 feet. So this plane is 4,000 feet above the ground. What is the horizontal distance between the plane and the airport? So we have to figure out what this length is here. So if the plane would drop straight down, what's the distance from there back to the airport? So thinking back to our right triangle trig functions that we learned last week, we have SO, CA, TOA. And we know this angle right here. We know the opposite, and this would be called the adjacent. It is touching the angle we are that we know that we're talking about. So opposite and adjacent would be O and A, so that's tangent. So the tangent of 41 is going to be equal to the opposite, which would be 4,000, over the adjacent, which is x here. We don't know what that is, so we have to figure that out. So I am going to multiply both sides by x. So I would have 4,000 here. And the tangent of 41 comes out to be approximately 87 hundredths. So we would have 87 hundredths times x. And then we would divide by that. So they would cancel here. We have x equals 4,000 divided by 87 hundredths is 4,597.7. And it says in the directions to round to the nearest foot. So this would be approximately 4,598 feet. Now, if we wanted an even more accurate estimation of how far away the plane would be from the airport, then we would simply type in 4,000 divided by the tangent of 41. And we would get 4,601.5. So they're close, but when we use the actual tangent 41 in our calculator, when we're doing the division, instead of rounding it to the 0.87, we get a little bit more accurate number. And I will take both. I don't care which way you do it. But I wanted to show you that you could possibly get two different answers. All right, example 3 here. A forest ranger in a 90-foot observation tower sees a fire. So he's up 90 feet in this observation tower up here, and he can see a fire. So the fire would be on the ground. So there's our fire. The angle of depression to the fire is 7 degrees. Now, angle of depression means that we're going down from our horizontal line. This right here is going up from our horizontal line. So that angle right there would not be our 7 degrees. We actually have to imagine that there's another horizontal line going out here. And this angle would be 7 degrees because we are going down from our horizontal line to make an angle of depression. Okay. What is the horizontal distance between the tower and the fire round to the nearest foot? So the horizontal distance would be right here. Oops, not 7. That would be x. That's what we're trying to find. All right, so what we know from our very first picture example up there with the angles of depression and elevation is that if there's alternate interior angles, those angles would be the exact same measure. So with this angle up here being 7 degrees, I know that this angle right here is 7 degrees because they are alternate interior angles. They are on the inside opposites. So we need to figure out what x is. And looking at this picture, I know an opposite. This would be our opposite. And this would be an adjacent side because it's touching our angles. So opposite and adjacent would be, again, tangent. So the tangent of 7 is going to equal our opposite number, which is 90, over our adjacent number, which is x. So I would have to multiply both sides by x. So the tangent of 7 times x is going to be equal to 90. And then I'm going to divide both sides by the tangent of 7 to figure out what x is. I'm not recording right now because I lost it. 90 divided by the tangent of 7 is 732.99. So therefore, it says round to the nearest foot, so that's approximately 733 feet. Now, if you figured out the tangent of 7 beforehand, you would have gotten 0.12. So you would have done 90 divided by 0.12, and you would have gotten an answer of about 750. So they're close, but they're not the exact same. So it depends on if you figure out the tangent of 7 beforehand or after. All right. We have one more example, but I'm looking at the time, so I think I'm going to have to do a second video because I'm going to run out of time on this one.